Chapter 1, Section 3 is all about properties of numbers. And so what we're going to do first here is go over some of the properties that you need to be familiar with. We're going to do some practice with you being able to identify the types of properties, and then I'm going to show you how you would use this in a problem. A lot of times you are so used to using these properties that you don't even realize that you're using them. And so the purpose of this lesson is for you to understand why we have these properties, what they mean for a problem, and how to use them if you needed to ever justify why you did something in a math problem. A lot of times these properties will show back up like if you take a geometry course and you have to start proving things as you're doing problems. One property that's not on your chart here that I want to just go ahead and get out of the way before we get into the chart is called the distributive property. If you just want to add this on to the top of your chart. The distributive property looks like this. You would have a quantity sitting in front of parentheses, and inside the parentheses you would be adding or subtracting other items. And what you would do is take that first term and multiply it into the parentheses. So a lot of times you'll see arrows get drawn. And so what you could do then is take A times the B and add that to whatever A times C would be. So, for example, if I had 2 times x plus 3, I could use the distributive property to multiply in, and that would say 2x plus 6. Let's get into our chart now here. So the first property is called the reflexive property. This is when something is equal to itself. So, for example, A equals A. So other things that you might see would be numbers, like 1 is equal to 1, or it could be a bigger quantity, like xy is equal to xy. Think about reflections when you think about the reflexive property. When you look in the mirror, you see yourself back looking at yourself. So a reflexive property is just when you have the same quantity twice. It's the exact same thing on both sides of the equal sign. Now, symmetric is similar to reflexive in that the items that you're dealing with on either side of the equal sign represent the same thing. They just maybe look a little bit different. And you can take the two items and you can switch them around. So, for example, if I had two quantities, x and y, and I'm saying that they're equal because they represent the same amount, I could take x and y and flip them around just to rewrite it if I needed to. So what this might look like with numbers is if I had 2 plus 3, and I said that that equals 5, then I could switch this around and put 5 first and set that equal to 2 plus 3. Because 2 plus 3 is 5, so it's really easy for you just to switch those quantities around. Transitive property is when you have several of these types of sentences being written. And so you're switching things around, but there's also some repetition happening. So what I like to point out in the definition here, if you look, it says x equals y and y equals z. Okay, if you look at those two sentences, you should hopefully notice that y got shared. Y was being used twice. So what they did then is they kind of skipped over the y and they said that x and z should be equal to each other. So here's what that might look like using numbers. If I had the quantity 3 plus 6, and I say that that's equal to 9, and if I also said, well, I could take 9 and rewrite that as 4 plus 5. If I look here, the 9 is being repeated, it's being shared. So what I could be able to say then is that the quantity 3 plus 6 should be equal to the quantity 4 plus 5. This next property, substitution, is used very often, especially in algebra. Anytime that you take something and you replace it with a quantity in the problem, you're using substitution. So when we were doing section 2 with order of operations, we had some problems that you had to plug in the values of x, y, and z first before you could do the math. That was using substitution. So if I had something like x times y, but then they said that x was equal to 3, I could replace x with 3 then and say that that's 3y. So another way you might see this is if you had the expression like 2x plus 7, and they might say if x is equal to 3, then what that means you could do is take 2, plug in the 3, use substitution to replace that, and then add the 7. And that would still work because you would then be able to solve by taking 2 times 3 and add 7 to that. These next two properties are both additive properties. So we've got additive identity and additive inverse. Additive identity says that you can add 0 to any number or any letter and it's not going to change the answer. So a plus 0 equals a, 0 plus 3 equals 3, or it could even be like 21 plus 0 equals 21. The additive inverse says that when you take a number and you add it to its opposite, it's going to equal 0. Opposites would be when you have something that's positive and something that's negative. So 4 plus negative 4, those are opposites. X plus negative x, those are opposites, and you can see that they equal 0. The negative doesn't have to come second. You could have the negative come first. So, for example, it could be negative 17 plus 17. Let me rewrite that a little bit. Negative 17 plus 17, that equals 0. And same with like letters. It could be negative a plus a equals 0. The next three all have the word multiplicative in them. So this is dealing with multiplication. The multiplicative identity says that you can take 1 times any number and it's going to equal that number. So 1 times c is c, 7 times 1 is 7. It could even be like 24 times 1 equals 24. Multiplicative property of 0 is if you take any number times 0, it's going to equal 0. And again, that could be 0 times anything, or it could be a number times 0. It could even be something larger, like x, y, z, all those letters times 0 is still going to be 0. Now, the multiplicative inverse says that if you take a number times its reciprocal, it equals 1. A reciprocal would be when you take a number and you flip it upside down. So think of the number as a fraction. So when I had 2/3, the reciprocal of that would be 3 over 2. So I flip the fraction upside down, I multiply them, and it equals 1. So if you had a whole number like 5, you would want to write 5 over 1 in order to write it as a fraction. Then you flip it upside down to 1 over 5, and if you multiply across, you get a 1. If your quantity was xy over 2, the reciprocal of that would be the flip, so it would be 2 over xy, and that would also just equal 1. The last two properties here, commutative and associative. Commutative says that you can add or multiply in any order. So it doesn't matter how you're starting to switch numbers or letters around, you're going to be able to add or multiply them and it's not going to affect the answer. So for some other examples, in addition to the ones I already have here, I could do 7 plus 5 equals 5 plus 7. Or you could do like 2 times 3 times 4. And say that that's the same thing as 2 times 4 times 3, where I'm just changing the order around. Now, associative, a lot of times the clue that something's going to be associative is that you might see parentheses in the problem. Not always, so don't always assume that because you see parentheses that means it's got to be associative. But a lot of times associative problems are going to have parentheses in them. What this means is that you're not changing the order of anything. So if you look at like the 7 plus 2 plus 3, if you look, the 7s are in the same spot. The 2s are in the same spot. The 3s are in the same spot. All I'm doing is changing my grouping. Like the first one had parentheses around the 7 and 2, while the second one has parentheses around the 2 and the 3. So I didn't change the order, I simply changed my group. So for example, if I had 9 plus 1 plus 6, I could change my grouping and put 9 plus 1 instead, and then add 6. And the same thing works with multiplication. If I had 3 times A and then times B, I could switch the grouping, put 3 first, and then do A times B second. So what I want you to do here is on the next page, there are a few practice problems. So I want you to pause the video, take as much time as you need here, try to go through the list and write down what property you think is being shown. And then come back and press play, and I will walk through what the answer should have been. All right, for this first one, all they're doing is changing the order of the x and the 4, so that's commutative. The second one, you're taking it plus 0, so you're adding 0 to it. That's not going to change the answer at all or change the quantity, so that would be the additive identity property. The next one, they changed the grouping because they moved the parentheses, so that would be your associative property. For the next one, you have this x plus negative x. Those are opposites, and they became a 0, so that would be additive inverse. For the next one here, they did not change the numbers at all, and they didn't change the grouping either. They left the grouping still around the 3 and the 4, but they did switch the order of 3 and 4. So this one is actually commutative. The next one you're multiplying by 1, so that would be the multiplicative identity. The next one is you have reciprocals being multiplied together and you're getting a 1, so that would be the multiplicative inverse. And the last one here, you were multiplying by 0, so that would be the multiplicative property of 0. Counterexamples would be things that show why something doesn't work for all situations. So when we went over the commutative and associative properties, those were only talking about if you're adding or multiplying numbers. If you start dividing or you start subtracting, it is not going to work the same way, and I want to show you why. So for this first one, this would be an example of the associative because they're changing the grouping. So on the left-hand side, you've got 8 divided by 2, so you'd have to do that first. So that would be a 4 divided by 2, which would leave you with 2. Now on the right-hand side, they changed the grouping, so you take the 2 divided by 2 first, which would be 1. So then you have 8 divided by 1, which would be 8. These are not equal to each other. So that's why division doesn't work. You can't just change the order or change the grouping. It's not going to work the same way. You're not going to get the same answer all the time. Same thing happens with the commutative property. You can't just switch the order when you're subtracting and expect to get the same results. So 3 minus 2 would be a 1, and 2 minus 3 would be negative 1, and those are not the same. If you're ever looking at something and they talk about things being equivalent, so if they say expressions are equivalent to each other, that just means that they have the same value. When we're dealing with these properties, we had a lot of equal signs, so we had a lot of equivalent expressions being shown as I walked through all those properties on that front page. An example of when you might see equivalent expressions being used in a problem. Let's take a look at this first one. So in a recent season, the Kansas Jayhawks had 15 guards, 4 forwards, and 3 centers on their roster. Write 2 equivalent expressions using the associative property that can be used to find the total number of players on their roster. So to find the total, we would do 15 plus 4 plus 3. Now the associative property says that you can change the grouping, so you can group numbers together however you want. So for this first grouping, I put the 15 and the 4 together, and then added on the 3. And the second way I could have done it is group the 4 and 3 together first, and then added on the 15. So that would be a way to show the associative property. So go ahead and read through that practice problem and try to write down what you think the expressions would be using the commutative property. So she earned $7 and $12. So you need to add those together. So one way to do that would be 7 plus 12. But the commutative property says that you could switch the numbers around. So instead I could do 12 plus 7 if I wanted to, and I would still get the same answer. All right, these next couple of examples are going to want us to simplify by using order of operations, but then also being able to justify what we did by using those properties that we've been talking about. So this first example, I start with 2.7 times 5 times 10. Now the first thing I did in this one is I switched the 10 and the 5 around using the commutative property, because that says that you can move numbers around if you would like to. And the reason why I did that is because since I have a decimal here, multiplying by a power of 10 is going to make that math easier, because I just need to move this decimal place 1 to the right. And that's how I got that 27. Then I have 27 times 5. I'm just going to multiply those. So that was using substitution, using multiplication. And then when I take that again and I get the 135, you're just using substitution. There's going to be times in problems where you use substitution a lot, because you're either just doing some quick math and you're replacing a value that you saw or something that you saw before with a new number. When you're using substitution, just provide what operation you use so I can kind of keep track if you were adding, subtracting, multiplying, or dividing. So go ahead and take a minute and try to do the practice problem. Okay, what I would have done first for this one is I noticed that I have a 5 and a negative 5, so I'm actually going to switch the order here. Of those two terms, and that's using commutative. Now, the reason why I did that is because these are opposites. So if I add those together, I'm going to get 0. They're going to go away. Because remember, we had that property of the additive inverse, which said that if you add opposites, you get 0. Now, if I add 0 to anything, it's not going to affect the answer, so I can basically drop the 0 from my problem now and just have 34 plus 3, and that would be the additive identity. And the last thing I really have to do is add those two numbers together and get 37. And so I would say I used substitution. And I'm just going to put addition after that, or add for short. Or you could do a little plus sign if you wanted to. All right, I've got a couple more examples here to walk through. So with this first one, it says 3 plus, in parentheses, 2 plus x. What I did first is I used the associative property to change my grouping, because I can't combine 2 and x because I don't know what x is. So I moved the parentheses to go around the 3 and the 2 because I can add those together, and that became 5, and then I still have that plus x. And that reason was just using substitution, because all I did was add the 3 and the 2. For the next one, I did something similar to get me started. I first switched the order of the x and the 3, because I'm going to want to group my 3 and my 2 together, so I need to get them next to each other. So you can see how I switched it from saying 3x to x times 3, and that's using the commutative property, because that says I can rearrange the order. Then I changed my grouping, so I put my parentheses around the 3 and the 2 instead, using the associative property. Then I took 3 times the 2 to get 6, and that was just using substitution with multiplication. But I don't want the x to come first. I like the number to come first. So then what I did is I switched it one more time. I switched the order of those terms, and that's just using the commutative property once again. So there's a couple of practice problems at the bottom here for you to try to work through on your own. So pause the video here, take a minute to do these problems, look up above at what we've been doing to try to help you work through these problems if you need to, and then we'll go over the answers if you want to resume watching. So for this first one, I switched my grouping so that it went around the 5 and the 4, and that was using the associative property. Then I multiplied, so 5 times 4 is 20, and then x, and that would just be using substitution with multiplication being the reason there, because I just multiplied 5 times 4. For the second practice problem, I switched my order of my x and my 3 around first, and that's using the commutative property. Then I'm going to change my grouping so that I have parentheses around the 3 and the 4. That's using associative. Then I'm going to add the 3 and the 4, and that would be 7. And that's just using substitution with addition being the reason.